All right, so we're on 3.5C, rational functions. A rational function is one that can be written as a polynomial divided by a polynomial, okay? So it's just a polynomial divided by another polynomial. That's it, okay? A rational function may have one or more types of discontinuities. Okay, our first one that we're going to talk about is called a whole. So you can have a whole in your function, and that's called a removable discontinuity.
What is discontinuity?
It's what causes me to stop or break in my function. So our asymptotes are our discontinuities, right? Because we have to stop and restart, right? Okay, we can have a vertical asymptote. And a vertical asymptote is a non-removable discontinuity. Keyword here is non. Okay, and then lastly, a horizontal. So the difference between a reciprocal function and a rational function is you're not adding on a k value, okay? It is just simply one polynomial in the numerator and one polynomial in the denominator, okay? So I wrote a lot of it out for you so you wouldn't have to. So the first thing we're going to look at is our two types of discontinuity. The first one is our removable. Okay? And how do you know if you have a removable discontinuity? The way that you know if you have a removable discontinuity, basically what this is saying is if you factor the numerator and denominator, and they have a common factor, then that's where your removable discontinuity is.
I forgot what the factor was.
These are factors, the binomials. These are our factors. So notice here that each one has x minus 5, right? There's an x minus 5 in the numerator and an x minus 5 in the denominator. So I can remove them. Does that make sense? So I can remove them, which means that there's going to be a whole at x equals 5. Why is it at x equals 5? Because at x minus 5, which means x has to equal 5, right? That's where our removable lies. Yes, it was a whole because I removed it. Okay? All right. Next one is our non-removable. So our non-removable happens only if the degree, what is it? Oh, our non-removable happens only if in our denominator, we still have a factor or we still have a polynomial that can be set equal to 0. Okay? That's what's going to be the main thing. Main thing is if there is something left in the denominator, because our denominator can't do what? Be 0. Remember, your denominator can't be 0. It is okay for 0 to be in the numerator, but it is a no-go for the 0 to be in the denominator. Okay? That's where our asymptotes come from. That's how you get a vertical asymptote. So when we look at this rational function, we have x squared and x minus 3. Can I remove anything? No. So now I'm going to focus on x minus 3. What can x not be? So this cannot equal 0. 3. So therefore I have a vertical asymptote at x equals 3. And that's because x minus 3 equals 0. So x cannot equal 3. And is that what happens when we write a vertical asymptote? Yeah. We're saying what our x cannot be, right?
So what's that word?
Asymptote?
It's what it cannot be?
It's what it cannot be. That's where our imaginary boundary line would be. Okay? All right. Next is our, what is this thing called? Uh-huh.
Is x equal 5?
We have a whole at 5. And that's because it was what? It was taking it out. If I can take it out, it creates a hole. If I can't take it out, it makes a what? A vertical asymptote. A hole is literally a hole in your graph. There's a space, a small, tiny space that will separate your graph. Yeah,
Oh,
it's a hole, like literally, there's a hole in my graph. Yeah.
oh.
Thank you. Someone caught it. All right. All right, here we go. So next it says, we're gonna let P equals the degree of the numerator and Q equal the degree of the denominator, okay? I think I changed that to M and N. So why did I switch it? I didn't change your notes completely. These should be M, N, N. My bad, guys.
The numerator one and
Yeah. Yeah. I thought I changed it all the way, but I didn't. I apologize. I'm sorry. All right. So how do you know if you have a horizontal asymptote? Okay, these are your rules. If the degree of your numerator is less than the degree of your numerator,
Miss, I think you should put M less than because those songs I don't understand.
well, you write less than.
I've been in school, but I don't know how long I still know what a less than a greater sign is.
The one that almost looks like an L is less than.
I just do whatever this is eating, this is bigger number.
No, you see how this could almost be an L? That's your less than. M is less than N.
Oh, okay, it makes it has an L go this way.
Yes, exactly. L's go that way. And then greater's the other way.
The big number.
Yes. Okay, so in this case, oh man, this is funny. If M is less than N, that means that the degree of your numerator is less than the degree of your denominator, then you have a horizontal asymptote and it's automatically at y equals 0. Okay, if your M is greater than your N, then what does it say? No horizontal asymptote. We will worry about what it means later in pre-cal. Okay, well, for algebra 2, we just got to worry about no. Okay, all right. The last rule is if M equals N, so if the degree of your numerator equals the degree of your denominator, then you have a horizontal asymptote at y equals a divided by b. And a and b are your coefficients, so just the numbers. Exactly. That's what this is. So this is an example of when that happens. So notice here, for here, my M equals, what's the degree of my numerator? 2. What's the degree of my denominator? 2. It's my highest power. Remember, your degree is your highest power. What is degree?
So if it was Q,
highest power.
so if
3. Yeah. And notice that M and N are the same. So all that's telling you is you're taking your leading coefficients and dividing them. What is the leading coefficient here? 4. What is the leading coefficient here? So your horizontal asymptote is at 4/7.
Highest power of a variable or any?
Of the variable, yeah.
So it's like 2 cubed, it couldn't equal 3, it's really more.
It would be 3. It would be a third degree.
So the
Yeah.
M
Like, oh,
is
you
a-
said 2 cubed or x cubed?
2 cubed.
No, 2 cubed is 8. That's a number. Yeah, only the highest power of the variable. Okay? All right.
So the M is a big number, the N is a little number. The M is the big power in the.
M is your degree. Your highest,
The big degree. Is that
yes,
what M
the
is?
big degree.
And the N is a little degree.
No, it's still the big degree, but in the denominator.
Oh, okay.
Okay? That's why, shh, guys, degree of numerator, degree of denominator.
M is the numerator. Okay, never mind, never mind.
Yes.
I just thought it was like overall, but. Yeah, okay.
So when we are looking for the discontinuities, we first want to factor the numerator and denominator completely. Look for the values that are zeros of both numerator and denominator. And if they exist, then that means we have a hole. If I can't remove anything, do I have a hole? No. Okay, then you want to look for the values of the zeros of the denominator. And that's where our vertical asymptotes are going to come from. And then we're going to check for a horizontal asymptote by comparing the degrees.
Okay.
Okay, it sounds like a lot, but once we do, you'll be like, oh, this is easy. Okay, do we really? What time is it? No, that clock just lies to me, so it scares me. Okay, no, we're not stopping. We got this. We can do it in 5 minutes. Okay, here we go. So our polynomial and the numerator, it has a degree of 2. Our polynomial in the denominator has a degree of also 2. Agreed? All right. Now we're going to factor them. The first thing we want to do you remember asking ourselves what multiplies to give me -6, but adds to give me 1? What multiplies to give me -6, but adds to give me 1? What kind of 3 and 2?
Oh,
There we go. Good job. A -2 and a +3. Those good old factoring skills. Okay. In the denominator, this is greatest common factor, right? What is the greatest common factor here? 3. So I can factor out a 3, and I'm left with -4. Okay. This is a special case. Anyone remember what this special case does? Anyone remember this special case for factoring? Difference of tables? Really? Tables? Difference of tables. No, difference of 2 squares. Okay. What that means is that when you factor it, it can be factored again. So it becomes x -2 and x +2. Are those ringing any bells? A little bit of factoring. So we're fully factored. Okay, step 2. Is there anything that can be removed? Yes. What can be removed? X -2. So that tells me I have a what? A whole. And the whole is at 2. Good job. 3. Once you remove your whole, you're going to look and see what is left in your denominator. What do we have left in our denominator? 3 doesn't have a variable, so it doesn't matter. So what's the...
X +3 and X +2.
So this is just a number, but this is a factor. So we're left with x +2 = 0. So where's our vertical asymptote? At 2. Our vertical asymptote is at x = what? What kind of 2 though? It's -2. Okay. And then lastly is 4. It's just identifying our horizontal. That's going back to our degrees, where our degree is greater than, less than, or equal to. Equal to. And what did it say you do if they're equal to? The A over B. Your leading what? Coefficients. So if there's no 1 here, it's Casper the Friendly 1. And then this one is 3. So where's our horizontal? 1/3. And you have now found all of your discontinuities. And I told you we could do it in under 5 minutes. We did. The bell didn't ring. We did it under 5 minutes. We did it in under 5 minutes. All right, so this is where we'll pick up tomorrow. Thank you for a great day.